before I mentioned that there is many models in protein design, protein structure generation, but all of these models seem to share a set of trade-offs that they do some things well, other things, well, not as well. And these trade-offs kind of range around the quality of generated structures. So how designable are the structures and how well do they fit the specifications we feed in? The flexibility of the method. So what types of different tasks can we solve with the method without having to try a new model? And finally, the speed of the method. So the throughput we can achieve, how many designs we can churn out per minute. And also, what is very important for experimentation here is the time to first design. So how long do we have to wait to see the first structure out of the model to see if we have to change anything? And so most diffusion models, like RF diffusion or Genie, they fall somewhere along the quality and speed axis. So where they produce reasonable design abilities at reasonably high speed, but they lack flexibility as they have to be retrained from task to task. For example, if you want to do binder design, you have to train a separate model. If you want to do motif scaffolding, you have to train a separate model and so on. On the other hand, hallucination-based methods like RSO, they give pretty good quality and are very flexible, but they are also very slow. And then there's Chroma, which for some reason seems to be very flexible and very fast, but the designability lags behind comparable models. So we kind of want to be able to improve the models and pipelines here to get somewhere in the middle of this triangle. And also, we need to be able to go beyond data limitations. So there's lots of types of proteins where there is very little data in the PDB, or the data diversity is low. One of these cases is antibodies. There's just not many antibody-antigen complexes in the PDB. And another very pressing case in this case is proteins that change conformation upon some stimulus. And because the PDB is mostly snapshots, mostly crystal structures, which show a single snapshot of a protein, uh, there is very little data on conformational change of proteins that can be extracted from there. So either we need to improve the data situation, or what is easier computationally is we need to somehow creatively force our models to do out of distribution generation.